Thank you, Stefan, and thank you, everyone. And I'm really glad I can be here to meet, friends I know in the past and new friends each year. And as Stefan said, PNG has been working with Baselab since long time ago. Before even I joined the company, strategically try to move forward our research and innovation in research and development, in marketing, in process, almost on every aspect. In particular, Michael Thompson is really the cornerstone to bring in this capability and also develop a lot of the original capabilities, and then collaborated with Baselab to bring that into the software to share with the broad community. So today, for the presentation, I'm gonna try to talk through the project we have been working on. How do we leverage generative AI and the causal inference to disrupt innovation? I mean, mainly gonna be on the methodology, high level description of the project. Apparently, we cannot share any data or even any anonymized case studies. So I'm gonna share two projects we are working on. The first one is we term it AI BBN, and I'm gonna explain the difference later on, why we term it that way. And the second one, we call it a science sedge for causal inference. So here is AI BBN. And the way we call it AI BBN is simply say, we use this to perform different tasks than we regularly using Baselab to do. So Baselab is generally, we use that a lot to analyze regular survey data, like you launch a blind test, concept test study, or identify the test study, in-home study, etc. As long as you have tabular data, without that missingness, we are using Baselab still every day, almost. And my colleague G is here, or maybe he has to attend a meeting somewhere. G is in charge of Baselab and the training of Baselab, and both Shu and Candence are also colleagues use this regularly, use Baselab regularly. So here, on the top is, you can think of, the main reason we need to build our own API is to facilitate the automatic building of the network on large scale of data. And also the data has a characteristic is high sparsity, is very sparse data. Specifically, for example, this is consumer review and rating data. Let's say review on Amazon, on Walmart. You took that review and then you run topic analysis on that review. You're gonna generate essentially for each of the review, you're gonna have a few topics, right? But at PNG, for each of the product category, you could have, let's say, 100 topics. For example, scent of a product, right? It could be scent of the product itself, scent of the laundry detergent, scent of the laundry after you use the product, scent of the wet laundry, scent of the dry laundry, etc. You have probably more than 100 topics for each of the product category. But the reality is for each of the review, even some consumer may write really long review, but still maybe just a few topics mentioned by that review. So in this case, you have a lot of missing topics. You simply don't have a complete data point. This makes the imputation or any other methodology to do the same, make it a really challenge. So last year, I believe even either last year or 2 years ago, we presented the same on doing the missing data using different methods. G is also part of the research project. So that's why we need to write a specific instance to do this automatically. I mean, other than sparsity, you can think of, we have each of the product category. For example, the shampoo, right? Shampoo we own multiple brands in multiple market. For each of the brand in each of the market, for each 2 years or 1 year, if you have to manually build a BBN model, that's unmanageable. The good thing for here is the data, they're sparse, but they're standardized already. It's already topics or sentiments or something. You don't have to manually clean the data anymore. The main challenge is the volume and the numbers and also the sparsity. So that's the main reason we built the AI BBN. That's on the top part. But the BBN, like you learn the BBN network structure. What's going on here? From base lab or from any other software or open source package is non-causal by nature, right? Of course, the bottom part, what we try to do is, traditionally what you can do before GenAI come in, you can say, okay, I present this learned network structure to one expert. If you have access to expert, simply say whether the direction makes sense or not, right? If you say makes sense, you keep that. If say you should reverse link, you reverse the link. And if you say this link doesn't make sense at all, you remove that link. And then you reparameterize your base lab, the BBN network structure. You get the CPT table aligned with expert knowledge, right? That's the way you identify causal BBN network. But these days, since GenAI is here, so what you can do is you can use LM as an expert, right? Let's say this is the procedure. The main thing I described is going to be mainly in the first paper, in the bottom, like published last year, end of last year. So the idea is, you use ChatGPT, let's say, as an expert. Initially, the input is going to be the tabular data, and also the metadata describes the variables, let's say. The tabular data, you use any machine learning algorithm, let's say BNLearn or other packages to learn an initial network structure. For example, this one, right? And then you simply ask ChatGPT, the prompt is going to be something like, let's say, whether C1, the question is whether C1 cause O or not. It's a multiple choice prompt. C1 cause O, O cause C1, non-relationship between C1 and O, or uncertain. If they say LM responds the multiple choice, right? Say C1 cause O, you do nothing. If they say O cause C1, you record that as a constraint. If they say uncertain, you do nothing. If they say you should remove this is spurious link, you put that down as another constraint. So these two constraints, for all the edges, right, you find whether they have this constraint or not. And then you use this constraint as prior to constrain your next iteration of learning a structure. So you repeat the procedure for several iterations. The idea is not the causality, the quality of the causality of this network improved significantly. We can see the results from the paper. So that's the main idea. The features, advantages, is like, you use LM as expert. It's much more efficient. And then you leverage both the numerical data in the tabular data format and also any texture data you can collect describe this tabular data. Of course, most important is the output, the quality of the causal network. So this is a little bit like the technical diagram, right? So we use both OpenAI and other open source model, like a mixture is the one we used intensively. So the reason we use mixture, like, I'm not sure, we cannot use ChatGPT API directly from OAI because of the security reason. We have to use ChatGPT through Azure, through Microsoft, because we have agreement with them regarding data security, data governance. So the thing, if you use ChatGPT through Azure, sometimes there are two issues, essentially. The major issue is, let's say in grooming, right? The shaving, if they're talking about shaving of a private part, that will trigger the filtering policy of Azure. Essentially, Azure thinks this is offensive. They will not give you response. In that case, we have to redirect the model to the model we deployed internally because we don't put any filter there. This is research tool, right? So that's the filtering policy. Of course, also the second reason is data security. Even we have agreement with Microsoft, but still you cannot use like highly restrictive or secret data on Azure ChatGPT. You don't want your data to reach to any external parties. So that's the main reason we use a alternative privately deployed model. Of course, after that, you can build the API either or interface using Plum or Shiny if you are doing that using Being Learn in R, or you use Streamlit or Fast API to build API and the front end if you are using Python. You can choose to use Being Learn or Causal Next, the popular package to learn your network structure. So that's a little bit technical, the thing, what do we do? I can first show you the top part. For example, this is one API. Once you have an API, you can run like each of the product segment, like, this is, you can think of, for each of the region, each of the segment, each different target metric for different topic level, different period, you build a model. You can build really large number of models automatically, right? Different platform can call this API, etc. You do that, you learn the structure, and then you get the drivers. You can send the thing in a backend database if you don't want to do that lively, because even this can run really fast. Still, if your data is really large volume, let's say 200,000 rows, it will take some time. So you can put that in your database, and then the dashboard, let's say Power BI, can connect with your database to get the visualization. And we also offer a web app sometime. This is, again, specifically for this specific data, like we call it a voice of consumer data. Voice of consumer meaning mainly the review and rating data. You craft that into topics, right? You have high sparsity. If you learn using BaseLab, I'm gonna show you one example really quick. So this is the one, you treat that as a filter. As I said, you can't do the imputation. You can check presentation last year or 2 years ago we did. You have if you have 10% missing, 20% missing, not a big deal. Any imputation may do a decent work. But if you have 50% missing, 60% missing, or even in our case, 90% of the topic will be missing for that review, right? This makes any imputation, anything will be super, super challenge. You simply cannot do that. So what we do is I'm not sure, in BaseLab, you can use that as a filtered state, right? Treat the missing as a special class. We also do that in BaseLab, in our algorithm. You can see here, this is the learning from the algorithm we used, and on the your left side is the thing. It's pretty much like a naive Bayes, or people call it star-like, sunbeam-like. We presented the details again in last conference when we do this. So the main reason, I guess, because the minimal description length penalize the complexity significantly, right? Essentially, the score function we use is different. Here, in Being Learn, you can use even just a simple hill climbing HC algorithm, right? BIC score. You can get some fine structure, but I want to point out that any of the structure, the strength is really low. Otherwise, BaseLab could have picked that up, right? Again, so the main reason we do this is automatic analysis at scale on large volume of high sparse data. That's really the reason why we do that. And of course, as I presented earlier, we do benchmark. We use Baselab as a gold standard to benchmark against the thing. We run this, let's say, on the regular data set without that many miscellaneous. Let's say, run that on concept study, run that on identified test study, run that on in-home survey, etc., right? And then get the drivers, get the structures, compare them with Baselab. They're, correct, consistent, and robust. We have all kinds of metrics to indicate you should be working correctly. So that's the first one on the regular BBing. And this one is you use the GenAI expert. Use LMS expert, how you do this. So this is in the paper, we can show the data. You see here on the left side, right? If you learn this, so each of the panel is a different study. Cancer is really the smaller. You know the ground truth mechanism in the data set. These are, you can think of the benchmark data set, right? After few iterations, you can see the purple one is the harming distance. Harming distance is essentially a measure the difference of your network versus the ground truth network. So the smaller, the better. That's a purple one. And the green one is the true positive rate. The higher, the better. Just a few iterations, you got really nice quality. In particular, the first two iterations, you get significant improvement. I hope this intuitively makes sense. It's like, you get an initial network structure, you present it to an expert. The first round, you will always gain more information from the expert than the following round. So that's the point. So this is one illustration of the learning on which study? I don't know, maybe child? Yeah, child, I believe you have 20 variables in the network, right? So the iteration one, you see that you try to remove, you try to change the colorful one, right? Iteration two, iteration three, you already get a much better quality in terms of causality. And if you wanted to quantify that, that's this table. Again, each column here, top and bottom, is a benchmark data set. In the benchmark data set, you know the ground truth mechanism, at least on large degree, crafted by, these are openly available data set. Like a cancer, you only have 5 variables. Child, you probably have 20 variables, and this one probably have 40 or 40 something, right? From smaller causal mechanism to large causal mechanism across the board, if you use this kind of mechanism, leverage generative AI expert, you improve the performance. Again, this is a harming distance, scaled harming distance. The smaller, the better. So the red number is the improvement in terms of reducing the harming distance. So this is like you can essentially substantially improve the quality of the causality codified in the network. So that's the point. Okay, so the summary. I wanted to make it clear. AIBB is not meant to replace Baselab in any way. Even on regular study, like the interface you saw, is not even close, anywhere close to Baselab interface, right? Most of the time we run the thing using the API in the backend to process something really quick to get the results. If they're really interested in the structure in the learning, they're gonna do further studies. So that's the point. And then, second point we wanted to make is, large language model can substantially improve the quality of causal BBing in just a few iterations. It opens really a new frontier of causal inference. So before I go to next project, any questions here?
Hold on 1 second.
Just terminology. You say improves causal inference or causal structure learning?
causal structure. That's the right term, probably.
Okay.
We didn't, I mean, once you have the right structure, the inference is depends on your CPT table, right?
That's
How
right.
precise is your CPT table?
So is it improving the structure or both?
Structure.
Okay, probably indirectly the inference as well, maybe, right? Assuming you have the right structure, the
Yeah,
inference are
because
correct.
the
Okay.
inference depends on how faithful the data you collected, right? The precision of your data you collected. But the structure is critically important. Most of the time, we would say, once you know the causal mechanism, purely know the structure, you solve more than half of your problem already.
How are you leveraging the LLM to keep revising the arcs? You use the LLM as a expert, but what kind of prompting or queries are you doing there to?
So this is what I described. Like, traditionally, if you check the literature, right? You have many variables you collect in your table, right? One naive way you can do is you just test pairwise whether A calls B or not, right? You can do that. The disadvantage is, of course, you have first, with the increasing number of variables, exponentially, you have exponentially larger number of pairs. Number two is, even pairwise relationship, you can really just connect them together and say this is the causal network. Because causal graph identify a causal graph is much, much harder than identify causal pairs. That's the point. So the novelty here in the paper is, it will give you an initial structure, and you only test the pairs on each of the edge in the initial structure. And then you do that iteratively, iteratively. The prompt you used is really simple. It's the multiple choice question. Simply say, for each of the edge with two nodes A and B, whether A calls B or not, whether choice 1, A calls B, choice 2, B calls A, choice 3, non-relationship, choice D, uncertain. And then, you put constraints according to the choice they made. That's the thing I described earlier. I mean, feel free to check the paper. It's really a nice framework. I mean, intuitively, it may be really simple, but that's the way how it works. You do this way, you reduce your computational burden. And also, you have the strictest, highest constraint you can have. Because traditionally, if you check the literature, let's say you use your prior knowledge. Your prior knowledge could be ancestral constraint. Ancestral constraint is simply A is related to B. How, you don't know. The expert simply say, I think A is related. A probably has some relationship with B. Could be a longer causal path.
So how is it making that determination between your multiple choice?
The multiple choice.
Well, your prompt gives it multiple choice.
Yeah.
But it's going to tell you one of those options, right? Categorically and mutually exclusive, one of those, right? So how is the LLM, OpenAI, Llama, whatever, going to say, okay, A, B, or C, categorically? Like, how does it do that?
You simply let the LM generate answer the question with A, or B, or C, or D. Let me show you the prompt.
Yeah, but how is it doing that is what I want to know. Because if you don't constrain it, right, to hallucinate, or if you just let it do its thing, then it just falls back on parametric knowledge, which might not even be applicable to P&G, right?
I agree. Right. I agree. That's a legitimate concern.
Right.
But most of the time, if you just ask a pairwise causal relationship, LM most of the time is good because it was trained on huge corpus of knowledge. But even given that, some of the things they say A calls B will be wrong. That's for sure. That's for sure. But with that, you still improve your causality, the structure learning in a much better degree. You saw the Hamming distance in the table. It's the same thing if Lionel is an expert in Bayes lab, let's say. If I ask a lot of the questions, let him to check the causality of a network, sometimes he may make a mistake. This is the same thing for even real human expert, right? Likewise, for every expert, you cannot guarantee even expert to give you the all the right causal graph.
That's the point. Like subject matter expert versus data-driven approaches. Who overrides whom at what point, right?
Yeah. Let me put it this way. If you purely, this simple task to perform, one human, a group of human and the LM, right? You just say these are the 2,000 pairs. Identify whether each of the pair A equals B or not, B equals A or no relationship, uncertain or not. If you benchmark their benchmark data set, right, crafted by expert, you can check the paper maybe 2 years ago, this should be the one you also saw from Microsoft, right? LM outperform human by large margin to perform this simple pairwise reasoning, let's say. They are not good at reasoning graph yet, but if you can decompose your question into like the one they did, right? It's good. That's the benchmark you saw in the table.
What paper was that? Was that the first reference paper that you put up there?
Yes. Yeah, we can talk in detail.
Okay.
I don't want running too over before lunch.
Yeah. Thank you.
Yeah.
Thank you. That was
problem.
exciting. Yeah.
It is. So the second one, the tool we call the science stage. So here's the idea. The earlier AIBB in the data source we used is voice of consumer, like review data, consumer comments, or even the complaints they call us, say your product, the package was bad, caused allergy or something, right? But we believe there are much more value in scientific paper, technical blog to be extracted than, at least not less value than the insight you can derive from consumer comments, from Reddit, from tweets. So the science stage is try to designed to extract insight from, technical document, put it this way. So in the bottom part here, this is where is my, the bottom part here, there are two sets of tools. The bottom part is simply, let's say, you just have a research question, you have an inspiration, you have an idea somewhere. You don't have any data collected yet. But you wanted to know what people have been working on in this field by that's typical the way you do research, right? So what we can do here is, you punch in your research question. In the back end, the bottom part is a Langchain agent. Later on, I can describe a little bit detail next slide. So essentially what you do is, the first thing you do is you decompose your research questions into queries. Why you do that? Because the way you ask a question may not be the best way or efficient way to query the internet or to search the database. That's why sometimes when you Google something, Google always says, do you mean this? Or suggest something for you. That's essentially the first step you do. You decompose the research question into queries. And then the second step, you use the queries to query the internet, pragmatically, of course. And then after the result returned, let's say the first query return some URL, depends on your search the internet, or you just search let's say archive database. Archive is the open source scientific database, right? After return the thing, you took the, let's say, top and relevant URL, all the papers. You can either scrape the paper, scrape the website, consume the information there, right? Or digest the PDF papers, do a summary on each of the relevant one, and then send the summary to next component. So the final component is, it will write a scientific report based on these summaries with the reference. Of course, the feature is, you have the latest information. You have the structural report, depends on each of the steps, the instruction, the prompt you put in the interface. So it's like it can quickly, from research idea, to give you a structured research report with the reference. So in Base Lab, you also have the research report, right? But it would be nice, you also give the reference, right? So once you have the research report, you read it, you think, hey, it makes sense, right? You can customize that, of course, because you have the the prompt, you can change that. We give you the template to do that. You think it's really nice, the inference, I really wanted to check the reference. And then you can download the reference and then use the top part. Treat that as a chatbot. You can use the PDF papers or even your own document, investigate in detail simple questions interactively. It's a RAG called Retrieve Augmented Generation. You can think of a chatbot. The thing different from chatbot is chatbot will give you an answer, use the generic knowledge it obtained during the training. But RAG will generate an answer based on the document you provided. That's the difference. So that's really the two set of functionalities it try to achieve. By the way, there are commercial tools to achieve the bottom part. Let's say if you use consensus AI or perplexity AI, I'm not sure some of you know this, they are essentially doing the bottom part, but they charge you a monthly $20 to do that, or $200 per year to do that kind of thing. Plus, you cannot customize the report. I mean, the structure may be not as nice. So this is a little bit technical on the part. First, again, we have both the best performing commercial model, ChatGPT, and also one of the best performing, if not the best performing, a mixture at 7B. This probably 3 months or 4 months ago is the best one, of course. We use that for the same reason as I described earlier. And VB8 is a vector database. It's not a relational database because the way you build the chatbot, the RAG, you store the thing in vector database. We also have a graphical database called the Nebula. That's the main thing that will deliver the not purely causal inference, but to give you the interpretation because you have a graph. It's like a semantic graph Lino presented earlier. It's not a causal graph, let's say. It's a semantic graph. A Nebula graph is a graphical model, knowledge graphical model. This is a database. You can put your structure, triplet, you identify it there. We also have a Galileo. Galileo is try to monitor the usage because we don't track users, but we wanted to know collectively how users use this, what is the pattern, how do you improve this, etc. And we also use Hugging Face during the embedding time because the way, if you use OpenAI, it charges you by consumption, right? How many tokens you used. But Hugging Face, we have like embedding-wise, the quality is good enough. Again, you can use Streamlit as a front end. We use Streamlit. So either you generate a report or you generate the answer with a knowledge graph. So here is the interface. Unfortunately, I cannot show you the real example. We used all demo on the real tool. So on top right is you generate the report. That's my PhD research. So it's not related to PNG, so you can do that. You punch in your question and you select your like a search scope. In this case, I wanted to search archive database because I only wanted to see technical papers. And you wanted to say decompose my research question into 3 queries. For each of the query, return top 3 relevant resource you find. And then you run, you can select. I didn't show that, but there are boxes you can customize your prompt based on the built-in template I gave you. Like, how many words you wanted to have, what is the reference style, etc. And on the bottom left, you see that's the chatbot. You upload your document, and then you select whether you just use vector database to do the chat, or you use both knowledge graph and the vector database to do the chat. So this is one example when you ask to generate a report. So for this one, the question is, what is the mixture of expert architecture in GenAI, right? That's relatively new. That's a report that I generated. I mean, if you know this area, there's at least decent results. So then if you ask the chatbot, the RAG, upload some documents. These are some just natural language processing related literature. You upload that, let's say you use the knowledge graph index, or you use both knowledge graph and the vector index. You can see, other than give you an answer on top of that, you will also get the semantic graph, knowledge graph here. And you can download the knowledge graph, the triplet on each of that. And you also see the strength. Essentially, if you have multiple links, meaning you were mentioned multiple times in the triplet, in the graph. And we believe one thing, you add the knowledge graph index, you significantly improve the quality of your response. And number two, you have a nice visualization to increase, to give you the interpretation of the answers it generated. So we are, as humans, we are really good at identifying the relationships from the semantic graph. So that's at the high level, what Science Sage will do. We say, with graphical model, with knowledge graph, without the graphical model, we played a lot. That will aid the causal flavor, or at least give you some interpretability of the answer it's generated. Plus, you also have the reference. I didn't show it here. You can also show which document. Let's say you use multiple documents here. It will say which document on which page it generates the answer. So here's the summary for Science Stage. So Science Stage can generate an answer with a knowledge graph to assist causal inference. Science Stage can search internet or scientific paper database based on a research question. It can then generate a research report with references based on the latest relevant information. I think that's it. Thank you.